I'm Vanessa Wong and I coordinate the Bachelor of Science Advanced research degree. And I actually sit in the School of Earth, Atmosphere and Environment. So I guess just a brief background in terms of what I do. I'm a soil scientist and I studied environmental science. So I study a whole lot of stuff below ground and I look at how soils interact with plants and look at how different amendments or how we change the way we manage our soils affects plant growth. I also look at building 3D models using different modeling techniques, and I get to use some pretty cool high-end equipment like the synchrotron across the road to look at soils in very high resolution. So if you want to talk more about soils, I'm always happy to talk about soils. But today, or tonight, we're going to talk about advanced research. So why should you study the advanced, the Bachelor of Science Advanced Research? Well, there's loads of different reasons, but you get a whole lot of opportunities to work alongside some of the world's best researchers at Monash, and you get to work with them one-on-one or in small groups. So you get access to some of the leading academics across a whole range of different areas in science. It's also flexible, so you'll be able to accelerate your learning. You can obtain pre-approval for some of the advanced units that we offer, and in some cases you can gain early entry into second year units in your first year. You'll also build practical skills, particularly around your research component, because as we know, and particularly in these last few months, as we've seen the research come out really quickly around COVID-19 and all of the questions we have around that, you can see that the research that's done is done in big teams, or it's done in groups, and it's no longer done at an individual level. So we get you to learn how to work in those teams and research in those teams. So you gain a whole lot of practical skills in terms of teamwork, collaboration, communication, and project management. We also provide you with a range of academic mentors, or we provide you access to academic mentors who may or may not be in your research field. So you get to know the academics at Monash on more of an informal level as well. And you have your own common room, which is normally shared with the Global Challenges students. I can see a few giggles in the panels. At the moment, unfortunately, none of us are using that common room, but you do have your own space on campus where you get to interact with people in the advanced degrees. And once those international borders open, you also have access to international research scholarships as well. With the University of Warwick, Monash Leipzig exchange program, and also a range of other universities in North America and Europe predominantly, but there really isn't sort of any limitations in terms of where you can go. So what does this degree look like? This degree allows you to fill your entire degree with science, which I think is amazing. And it means that if you love science, you can fill every single unit with science units. So we have in your first year, you have three units of science, and then an elective option. In terms of the degree itself, students complete 2 science majors. So like I said, you do a lot of science in this degree, and research training can start from your second year. Actually it can start from the end of your first year, and I'll explain a little bit more about that in the next slide or so. As I've said earlier, you have access to mentors in terms of academic mentors, but what I also think is fantastic is that we set you up with a group of peer mentors as well. So there may be some questions or some aspects of your degree that you're not perhaps comfortable asking your academic mentor about, or you just sort of want some hints and tips about the degree from students who have already been there before. So we set up peer mentor groups within disciplines so that we can allow that to happen. And by the end of your degree, there is the potential for direct entry into a PhD program. as well. So if you meet those requirements. And the ATAR enter score is, the clearly in score is 95. So, oh, and I should also mention that the advanced research degree is an honours degree, so it is a 4-year degree. So you can choose from one of those 27 majors that that Simon mentioned earlier, and you have the freedom to choose whatever major that you're interested in. And what's really great about this degree is that you can combine majors to work towards particular specializations of interest to you. So, for example, if you're really interested in paleontology, then you would pair an earth science major with a biology major. Or if you're interested in forensic science, you might look at pairing chemistry with genetics as your major. So there's all sorts of different majors that you can start to pair together, which allows you, I guess, more flexibility as well if you love lots of different areas of science. In terms of the course requirements, as I said, you need to choose at least 2 science majors or an extended major and a minor sequence in different science disciplines. And I'm here to help you work that out and also work out which majors you might be interested in and what units to take in those majors. There is a level 2 or a second year core unit that all students do, which is scientific practice and communication. So that's a science communication specific core unit that all advanced students do. So Sci 2015 is open only to advanced research students and those students who obtain an average greater than 70 in their first year. A core requirement as well is a 3rd year research project unit, which is relative to the major that you're completing, and then students go into a 4th year honours year. So in terms of maintaining the particular grade within the course, students need to maintain an average of more than 70%. So that's a distinction average across all science units in each calendar year. And this course or this degree is only available for students under a full-time enrolment. So they need to enroll in a full-time enrolment study load. And it's a single degree only. So it's not offered as a double degree option. In terms of those electives that I showed you earlier, you can choose a range of non-science electives. So you can choose a maximum of 24 points from areas outside of science. So that's 4 units or 4 subjects outside of science. And these can include units from arts. So a lot of students choose a language or another humanities unit that they may be interested in. Students also look at engineering units and business and economics units. In some cases, there is permission required to enrol in those units. A lot of students enrol in IT units as an elective. Some medicine units are also available for advanced research students, and also fine arts units, which are based at the Caulfield campus. Or in my case, I would actually fill it with more science units because you can. So you can never have too much science. In terms of the research opportunities for advanced research students, you have an opportunity to start a research project from the end of your first year. So we offer Research First summer project units. So after you complete your first year, we have a range of summer scholarship research projects that are open only for advanced research students. In your second year, there are some schools offer second year research projects. So physics and chemistry offer second year research projects for those who want to start their physics and chemistry research in their second year or want to look more deeply into particular topics. There's also summer research projects offered at the end of the second year as well. A number of these are also paid, so you get paid to do research over your summer break, which is fantastic. Then you have your third year core research project. So that's across all, offered across all of the majors. There's also the potential, like I said earlier, to do an international research exchange project once borders open, and then students can go into their fourth year honours project. So what do some of these projects look like? This is actually an example that was sent to me just the other day by Kaylin O'Connor, who's in their second year this year, and they completed their summer research project, and they said that this was only available to them because they were in this course. And this is really neat because Kaylin had only completed their first year, so 8 units in science, and then got to look at labeling cancer cells with fluorescent molecules and start imaging them as part of their project, to look at anti-cancer drugs on spindle formation, multipolarity, and chromosome division in cancer cells. If you're interested in more details, I'm sure I can put you into contact with Kaylin about that project. So that's really neat because that was done at the end of their first year, and you can see that they've got a whole heap of data, and it's contributed to a much larger project. There's also the third year research project. So Tanvi Otsa finished her honours project last year, and in her third year core research project, she actually got to go to an international conference to talk about, or to present the work that she did on coastal adaptation in small towns. So she got to listen to the Prime Minister of New Zealand, Jacinda Ardern, and also the Crown Prince of Norway talk about collective action on the Sustainable Development Goals. And so you can see Tanvi there next to a poster, and she went over with this group from Monash, who are part of the Monash Sustainability Institute. So that was a fantastic opportunity for Tanvi. And in the Faculty of Science, we also offer a science internship unit, which students can take under their electives. So the science internship allows students to be based at a particular organisation and to practice their knowledge and skills that are developed in their course to hopefully develop their employability skills. So in this particular unit, students attend workshops to prepare them for a work placement, and then they spend some time in a workplace to develop an understanding of what scientists do in the professional world. And from more of a student perspective, like I said, we offer a mentoring program for advanced research students, and the aim is to connect incoming students to senior students. So these are the peer group mentoring groups, and also the academic mentors. So we also connect students to individual academics, and that gives you, I guess, a bit of an idea in terms of what research groups do and how they interact and what happens in research, and how do you do research in a university setting, and you get experience in that quite early on in your degree. So to set up the academic mentoring scheme, we also the Student Society runs the Academic Mixer, which is a casual event where students get to chat and network with the academics at Monash. So you can see some photos from last year's Academic Mixer with both, in this case, this was both for advanced research and for global challenges. Normally, advanced research students also have an OCamp, which unfortunately didn't run this year, and a research tour on campus. And again, the students get to see some of the advanced research facilities that are available at Monash. So this picture here is from the Zebra Core facility, where students got to go into the basement of biological sciences to see some of these model organisms that that some of the researchers use for their studies. There's also a dinner, so an orientation dinner, again for advanced research students and academics as well. So, so that's again another way to get to know your cohort. So this is specifically for incoming first year students, so you get to meet the other first year advanced research students and also meet some of the academics. And that was from last year in terms of the research camp. So yeah, you can see they had loads of fun. Just to finish up, I work quite closely with the Student Society. So the Student Society is the Monash Advanced Science Student Society, which we know, which we call Mass Cubed. So like I said, you have your own common room. So you can see the common room there. There's a lot of pizza that's consumed in that common room, and study days are organised, and study days, games nights, and study groups throughout the semester. In amongst all of that, Mass Cubed also organised the Mass Squared Student Conference. So the Mass Squared Student Conference is a Monash Advanced Science Student Showcase. And this is an opportunity for the advanced science students to present their research in a conference setting. And again, it's attended by academics and by the students themselves. So it's actually a really fantastic event to showcase some of the undergraduate research that's done at Monash. And just to finish up, in terms of the application process, so you apply through BTEC. Like I said, the ATAR Clearly In score is over 95, but then there are subject bonuses as well. And then you can see the subject marks or prerequisites for English, maths, methods, and science units. So yeah, I'll leave it there.